Ozzy and I have come in to get ready for a birthday party for my son. Pile of young kids coming along later on. We just need to think through what to do. Thanks for coming in, Ozzy. There's going to be 12 boys and 8 girls coming in. And I'm thinking of playing a game where we need one boy and one girl in each team. The game's called BG. Actually, one boy and one girl each form a team. Each team we call BG, BG1, BG2. 12 boys and 8 girls. How many teams will we have? Well, thanks for getting ready for this, Prof. It's pretty obvious, I guess. There's one BG team, 2, 3, 4, 5, 6, 7, 8, and we can't form any more. The number of teams we've got is limited by the number of girls that we have there. Maybe we need some more kids. I'll invite a few more boys along, huh? Nah, Prof, you can invite all the boys along you want. You can invite 100 boys. We're still only going to be able to get 8 teams. What's limiting everything is the number of girls. If you want more teams, you've got to bring more girls along. Pretty obvious, I'd have thought. Yeah, well, you're right, of course. Yeah. Well, instead of BG, why don't we play maybe B2G? We need 2 boys and 1 girl in every team. Every team being a B2G team. How many teams will we get? Again, we've still got our 12 boys and 8 girls. I've done this, I think it might help us to think it through. We got each team 2 boys and 1 girl. Yeah, thanks for doing this. 2 boys, 1 girl, 2 boys, 1 girl, another team, another team, another team, another team, another team. 1, 2, 3, 4, 5, 6. Yeah, of course. 6 teams we can get, Prof. This time there'll be some girls left over because the number of teams is limited by the sex that runs out first, and that's the boys. The boys are the limiting sex, the ones that run out first. If you want more, you've got to add more of the ones that limit how many teams we get. Yeah, so again, it's not going to be very good if 3 girls have to sit out. Well, it might be better if we play this other game that I'm thinking about, where we need teams of 1 boy and 2 girls. Guess what's that called? BG2. That is correct. I wonder if that would make it better for us. Well, no, Prof, that'd make it worse. We have 1 boy and 2 girls, 1 team, 2 teams, 3 teams, 4 teams. We'd only get 4 teams, and now there'd be 8 boys left over. Now it's the girls, the number of girls that's limiting how many teams we can get. If we want some more teams, there's no point getting more boys. We need more of the ones that run out first, because they're the one that limit how many teams. You got any more thoughts for any other games? I could think of perhaps a game called B12G8. Well, you're right, of course, Ozzy, but I'm being distracted while you're doing these sorts of thinking things through. My mind's going to something in chemistry to do with stoichiometry, how much of this and how much of this react to produce how much of that. And a section of that field called limiting reactants. I just happen to have, yeah, excuse me, Matteo. Yeah, suppose we were going to mix 2 solutions, one containing barium ions, maybe a barium nitrate solution, one containing sulfate ions, maybe a sodium sulfate solution, and we produce a precipitate of barium sulfate. And suppose in the amount of solution we pour in, there's 0.20 moles of barium ions and 0.10 moles of sulfate ions. How much how many moles, what amount in moles of barium sulfate precipitate would be formed? I think this is the same principle as getting ready for this party and forming games. Let's see, Prof. If 0.2 of a mole of this reacts, it would react with 0.2 of a mole of this, because it's 1 to 1. And the number of moles is the same proportion of number of ions, isn't it? So 0.2 of this would need 0.2 of that. Well, we haven't got 0.2 of that. By the time that 0.1 of a mole of this had reacted, this would have run out. This then is the limiting reagent as to how much of that stuff is formed, the limiting reactant. So the maximum amount of reaction that we can get is 0.1 of a mole of sulfate ions, 0.1 of a mole of barium ions. And since it's 1 plus 1 to produce 1, that'll give us 0.1 of a mole of barium sulfate precipitate. Is that right? Good, Ozzy. Yeah. One more example. Suppose we burn. This reaction is just like a burning reaction. It whooshes, lots of heat, flames. If we burn some sodium in chlorine gas, very reactive metal, very reactive non-metal, we form sodium chloride. Table salt. Yep, white salt would be formed. Suppose we had in a vessel some chlorine gas and we put in some sodium solid. We need to warm it up first. And there's the reaction. 2 moles and 1 mole produce 2 moles. Suppose that there was 0.1 of a mole of sodium metal and 0.1 of a mole of chlorine. How much sodium chloride would be formed? Let's go this way first, Prof. If 0.1 of a mole of this reacts, it would need 0.2 of a mole of sodium metal, but there isn't 0.2 of a mole there, there's only 0.1. This would run out, so this is what limits how much reaction happens. So this 0.1 doesn't have enough of this to react with. This is a limiting reagent. If we wanted more of that to be formed, we'd have to add more of the limiting reactant. Sometimes I call it limiting reagent, limiting reactant. I think you call it limiting reactant, Prof, mostly, don't you? So we have to base always the amount of what happens on the amount of the limiting reactant. So what would happen would be 0.1 of a mole of this would react with half as many moles, 0.050 of a mole of that. And now it doesn't matter whether we take this as a basis for calculating that or this. 2 gives 2, 0.1 gives 0.1 of a mole of sodium chloride. And of course we could use the amount in moles to work out masses, couldn't we? Yeah. I think I've got it, Prof. I think that's very clear. Thank you. Well, thanks, Ozzy. Yeah, all this stuff about limiting reactants is pretty easy, really, isn't it?